Okay, so let's solve the following IBP. Let's solve y prime is equal to the cosine of 3x subject to y of 0 is equal to 3. Again, here we have another example of separable first order ODE. It's clearly nonlinear, so I'll write the y prime in Leibniz notation as y dy dx equals the cosine of 3x. And after multiplying both sides by dx, I'll get y dy is equal to cosine of 3x dx. And now that everything is separated, I'll integrate on both sides. And on the left hand side, it's pretty simple. Just use my power law. I'll get y squared over 2. And on the right hand side, I have a u substitution to make. So here, let's go ahead and let u equal to 3x, and then our du would equal to 3 dx, or du over 3 is equal to dx. So I'll replace the dx with du over 3, and then the 3x with the u. I'll get the integral of the cosine of u times du over 3. And the 1/3 I could have pulled outside the integral because it's a constant. Well, the integral of the cosine of u is simply the sine of u. So I'll get 1/3 sine, and u is 3x. And then I'll add the arbitrary constant c. So I have y squared over 2 equal to 1/3 sine 3x plus c. And at this point, I'll go ahead and apply the initial conditions. So over here, I'll say, let's apply the initial condition. Y is 0 equals 3, so when x is 0, y is 3, I'll get 3 squared, which is 9 over 2, is equal to 1/3. The sine of 0 is 0, plus some constant, which just said that our constant is 9/2. So now I'll plug that back in. I get y squared over 2 equals 1/3 sine 3x plus 9/2. If I want to get an expression for y in terms of x, I'll multiply both sides by 2. That gives me y squared equals 2/3 sine of 3x plus 9. And now I have y squared, but I can sort of logically make sense of this if I look at the value of y. It's positive, it's at 3, because if I take the root of both sides, I get a plus minus on the right hand side. But since the y value is a positive 3, then it must be the positive root. So I get y is equal to the positive root of 2/3 sine 3x plus 9.